looking at notes 5-9 titled Funky Factoring. So today we're going to be looking at some factoring that you've already done in the past as well as some new factoring. So let's first review some old material just to have it fresh in your brain for what you'll need for today. So in the review material, Roman numeral 1, you're going to simplify on numbers 1 through 5, and you're going to factor on numbers 6 through 10. So 1 through 5 simplify. So square root of 16. We all know that the square root of 16 equals 4. We all know that the square root of 49 equals 7. And then we know that the square root of 81 is 9, but when you put that square root of negative 81 in there, that becomes a 9i. Okay, remember the negative 1 under the radical, under the square root, becomes I. Similarly, or likewise, the square root of negative 9 would be 3i, because the square root of 9 is 3, but you put the negative 1 under the radical, and that brings out the I. And then again, likewise, square root of negative 4, instead of it just being 2, would be 2i. So again, that's all review material. All right, so now let's look at 6 through 10, on which we're supposed to be factoring. So remember, x squared minus 16. Okay, a couple of things we need to talk about. So we've got two terms here, and both terms are perfect squares. And there's a difference or a subtraction sign in between. So just to refresh, this is called a difference of squares. Okay, the square root of x squared, if we know that all variables are positive, would be x. If we didn't know that all variables were positive, remember it'd be absolute value of x, but for now we're just assuming that we're dealing with positive variables. Okay, so the square root of x squared would be x, so that is what goes in the front of both factors. And then the square root of 16 is 4, and that's the second term in both factors. And remember that one is plus and one is minus. So that's our difference of squares formula for factoring. Okay, and remember, again, to check yourself, you could always FOIL this back out. X times x is x squared. The O and the I of FOIL would be negative 4x, positive 4x. Those would become 0, hence there is no B term here. And then 4 times negative 4 would be negative 16. Again, you could factor this using grouping with the T-chart method, but it just seems to be easier to know that it's a difference of squares and use this. Similar here on number 7. Again, you could do the T-chart method. The factors of A times C must add to B. And use the grouping method. That will always work. But again, we see clearly that with these two terms, they are both perfect squares and that we have a difference in between. So we go ahead and set up our two factors, knowing that the square root of 4x squared is 2x, and that the square root of 25 is 5. And then we know that we'd have one plus factor and one minus factor. And again, you could check it, you could FOIL it back out, it'll get you back to this. So just using variables, here again we have a difference of two perfect squares. We're going to set up our two factors, and we know that a is the square root of a squared. We know that b is the square root of b squared, so 1 plus b and 1 minus b. This little parentheses is bothering me. It's like connected to the two. Okay, there we go. Better. All right, so now similar here, difference of perfect squares. So setting up our two factors. The square root of x squared is x. The square root of y squared is y. So 1 plus y and 1 minus y. And last one here. What I want to point out here is, if you noticed all along, none of these had a GCF. However, on number 10, both terms are divisible by 2. And like I said, in all the previous problems, none of the two terms shared a factor in common. So in this case, these two terms share a 2 in common. So first, you want to factor out the 2, which would give us x squared minus 36. Again, double checking that it distributes back to the original. And then we notice inside here, this factor is now a difference of squares. So this would become 2 on the outside, of course, and then setting up our two factors, we would have x plus 6 and x minus 6. So on this one, this is our final answer. Okay, so that was just some refresher of some things you already knew. Now let's get to the new material, okay? And not that you couldn't have done this before, but it does kind of step it up a notch. So looking at what we have here, what I want everybody to be perfectly clear on is that this is still a single term, okay? This is one term. There's no plus or minus in between here. They're glued together with an implied times sign. So this is still one term. This is another term. So we're still dealing with two terms and a difference in between. If we're asked to factor, which I should have put up here, new material, factor. Okay, if you're being asked to factor, then I'm looking at, okay, I have two terms, it's a difference. Are these perfect squares so I can avoid grouping? I want to avoid grouping at all costs just because it's time consuming. And the answer is yes, these are perfect squares, each of these terms. So what is the square root of x squared y to the fourth? Well, it would be x y squared, because if you think about it, I want to give myself plenty of room. Xy squared times xy squared, if you multiply those two together, it would get you back to the original, x squared y to the fourth. Likewise, 9z to the 10th is a perfect square. It would be, your square root of 9z to the 10th would be 3z to the 5th. 3z to the 5th, because 3z to the 5th times 3z to the 5th would multiply back to 9z to the 10th. And again, remember 1 plus, 1 minus. Okay, so then we're done on that problem. So again, difference of squares helps us avoid having to group, factor by grouping. All right, so next problem. Another thing I do want to point out here is that notice there was no GCF. Neither term had factors in common. Similar here, we're always looking for that GCF first mentally. If I'm not speaking it, we're definitely doing it mentally. So again, here there's no GCF, and I'm looking for, okay, can I avoid factor by grouping? And the answer is yes, this is a difference. These are not perfect squares, but watch and learn. This is pretty cool. So the square root of x squared is x, and do we know the square root of 3? Well, no, it's not a pretty number, so you know what we're going to do? The square root of 3 is the square root of 3. All right, 1 plus 1 minus. If you check it, make sure, verify, x times x is x squared. The O and the I of FOIL, the negative x square root of 3 and positive x square root of 3 will cancel out. And what do you know? Positive square root of 3 times negative square root of 3 would get us back to negative 3. So even if these aren't perfect squares, it still can factor. It's not pretty, but it still can factor. Now we have the question of, well, these terms are both perfect squares, but that's not a difference. That's a sum. Okay, so all along, notice we have dealt with difference of squares, no sums. But what's really cool about math is you can always manipulate these problems. So what we're going to do is I'm going to use a different color, and I'm going to rewrite this problem. Okay, I'm going to rewrite this as x squared minus negative 16. Do you agree that this is the same as this? Isn't minus negative plus? Yes, it is. Minus negative turns positive, so this is really cool. Now we have a difference of squares. This is a perfect square as well as this is a perfect square. So we would have x in the first factor, x in the second factor, and then what is the square root of, this is why we practice this, negative 16. The square root of negative 16 is 4i. 1 plus, 1 minus. And again, you know, if you're wanting to verify, please do. I encourage you to. X times x gets you back to x squared. The outer and the inner, of course, one will be negative 4ix, one will be positive 4ix, and they'll turn to 0. And then 4i times negative 4i would be negative 16i squared, Well, if you recall, I squared equals -1, so negative 16 times -1 would bring us back to positive 16, so it does multiply back. Pretty cool, huh? So again, we have the same situation here on number 4. So it's not a difference of squares, but we're going to manipulate it to look like a difference of squares. All right, so now it's a difference, x squared minus -25. So now we do have a difference of 2 perfect squares. Okay, so it's going to be x and 1 plus 5i and 1 minus 5i, right? Because the square root of -25 is 5i. Okay, so let's try the next one. On the next one, first, we have to factor out that GCF of 2, I notice. So factor out the 2, you get x squared plus 9. Okay, and then after you get that, again, you don't have a difference of squares, you have a sum of squares. Do I need you to write this manipulation out every single time? No. Hopefully by now you just know, okay, well, if it's a sum instead of a subtract, a difference, then you're just going to have an I. So x plus 3i, x minus 3i. Okay, and this is our answer, and maybe I should go back and box all of these. So hopefully you're getting the hang of how this works, at least the ones where I manipulated all box. Okay, so now let's look at number 6. So on number 6, there's no GCF. We have a difference of perfect squares, so it's just going to be 7x plus 9, 7x minus 9, right? Because we had a difference of squares. On number 7, we have a different scenario because, first of all, we have a GCF. Our GCF is 4. Yes, these are already perfect squares, but if there's a GCF, you still have to take it out first. So 4 comes out. This becomes x squared plus 25. And again, this is not a difference of squares, so it would be one of the ones where you have to manipulate. But again, by now, hopefully you don't have to write it. Hopefully you can just say, okay, it's 4x plus 5i, x minus 5i. Okay, and again, the I only comes into play whenever you have a sum of squares. Okay, let's practice the next one. M squared minus 15. So no GCF, and it's difference, it's not sum, so this would be m plus square root of 15, m minus square root of 15. Because again, the square root of 15 is not a pretty number, so we're just going to leave it. We're just going to leave it like that. Okay, and then last but not least, b to the 6 plus 25. Again, there's no GCF. We can use difference of squares, even though this is a sum of squares. B to the 3rd is the square root of b to the 6th. So b to the 3rd, b to the 3rd. And again, since this is a plus, this will become plus 5i and minus 5i.